Hi, welcome to an Arduino tutorial from RoboJax. My name is Ahmed Shamshiri. I'm presenting this tutorial from Canada. In this tutorial, we're going to learn how we can control an actuator using two relays and Arduino, either two independent relay or a two dual relay module, using Arduino and two push buttons. I'm pressing one push button and it pushes, and release it, it will stop, and I press this one, it pulls it. I can release at any moment. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. In my all videos, under the video in the description, click show more and you will see the link directly to different section of the video. You can click on any of these links to jump directly to different section of the video. There are applications that you need, for example, to position something or push or pull, and then this will be attached to something to put some device to a position. For example, if you have a solar panel, you can put it at a certain position. You can close some arm or whatever you have. So one side will be attached to something and this to the other side, and then you can push and pull this and then position something. And these are offered at different voltages. I'm going to show you how to use two relays to control it, so you can get either two separate individual relays, I've taped them here, or you can buy a two relay module like this. And this is the package. When I purchased it, they shipped it like that. So nothing else here. The length from here to here is 30 centimeters, and this is a 200 millimeter actuator, which can expand from here 20 centimeters or 200 millimeters on that side. And here all the specs are written in Chinese. This is a 12 volts version. There was 24 and different versions, but I picked 12 volts. And the speed of this one is 15 millimeters per second. Amount of force that it can handle is 250 Newton. We have a motor here, and there are some gears which causes this shaft to rotate, and this is pushed out or pulled in. We have only two wires, and once you connect power here, this will either contract or expand depending on the polarity. And inside we have switches, inside on this side and on this side. When this is inside the actuator, as you can see, the ratio between the large gears and small one makes it very slow. Here this is another view from the other side. When this motor rotates, there are gears. As you can see on the motor, we have very small gear, and there are a lot of other gears that will reduce the speed of the rotation to this shaft. And this is a lead screw, and the main shaft that is connected to this will go backward and forward when this rotates. And here we have extended limit switch and then retract limit switch, two limit switch. When this reaches at the end, this plastic, this one, it will push this switch and will turn off the motor so it doesn't go further or doesn't push. And when it goes backward, this switch will be turned on, which means it will disconnect the motor. This is my 12 volts power supply. Let me just connect it. I don't know which way it will open, so yes. As you can see, it's expanding. If you read it here, it shows 220, because initially it was here, so it is 20 centimeters or 200 millimeters. To close this back, I have to change the polarity. Explain it to you. For the DC motor, this is a DC motor, and it has a specific polarity. For example, if I connect this power, don't worry about the wires, and at this location you see that it is now rotating counterclockwise. If I stop it, you will be able to see that this is rotating in this direction. Now you see I've connected this to the black wire. If I switch these wires, you will notice that the rotation, the direction of rotation of the motor has changed. As you can see now, it is rotating at this direction, clockwise. I've set this very slow so you can see it. What it means is that you can change the direction of rotation of a motor by switching the polarity. And I'm going to show you how to use two relays to change the direction of rotation of a motor using Arduino very easily. Now let me explain the relay module. I'm going to explain the two module next. So for the relay we have VCC. This will be connected to 5 volts, and this ground will be connected to ground of Arduino, and this is the N which will receive signal from Arduino. And we have here an LED. When we have power at these pins, this LED will turn on, telling us that there is power. When the signal receives and relay is energized to make the connection, this green LED will turn on, telling us that it has received signal. We do not worry about the circuits that is driving the relay. I have separate video explaining driving the relay with transistors and other components. The link will be below the video. At this side for the relay we have 3 terminals. One is called common, it's at the middle, and then on the right side this is labeled as NC, normally closed, and this has been labeled as normally open, and which I'm going to show you later. And we use 2 of this, and if you are using this type of relay module which has 2s, that you don't need separate 5 volts for this, 5 volts for this, because 5 volts it would be enough for both, and 2. And this module is available on eBay, AliExpress or Amazon, as well as this one. Here you might get it without this pin, doesn't matter, but for this one we have ground and VCC. VCC is on this side. You will connect 5 volts here, ground here, and this one is called N1, N2. So this is as if this is relay 1, relay 2, and input 1, input 2, and here N1 and 2 are here at the middle. And for the 2 terminals for each relay we have 3 terminals. Here is a 3 terminal for this, and the 3 terminal is for this. Exactly the same. And the beauty of this one is I have separate video explaining this, that it has optocoupler, meaning the circuit will be isolated totally from the other side, and it will be optically coupled. The signal goes via optocoupler device on the other side, so it's much safer. We have a battery. The positive goes through a switch to one terminal, and the negative goes to the other one. So the switch can be either on the line between the positive and the terminal, or we can have it at the negative at the terminal, doesn't matter. And when we connect the positive, for example, to the positive labeled terminal of the motor, because the motor will have a specific label, if you connect that positive to the positive and negative to the negative, it will rotate a certain direction, for example counterclockwise or CCW. And if you want to change the rotation, you can connect this positive, which was connected before there, now connected here, and the negative you connect it to the positive. Now the rotation will change. Before it was rotating counterclockwise, now it is rotating clockwise. By changing the polarity of the power to motor, we can change the direction. And we cannot connect a motor directly to Arduino, so we can send different signal because we need a driver. But because we are using relay, we will put, instead of driver, we will put a relay here between the Arduino and the motor, and we will be able to control the direction of rotation of motor. Here is how I've connected the relay. We will connect relay 1 and relay 2 in this way. This is normally closed, common, and normally open. These are the 3 pins. This is the coil, which will be either off or will be on. And here I've connected normally closed of relay 1 to normally closed of relay 2 to your power or positive line. And normally open of relay 2 is connected to normally open of relay 1, and it is connected to the ground. Your motor, one of the pin will be connected to common of relay 2, and the other pin will be connected to common of relay 1. And here in this case relay 2 is off and relay 1 is on, so this coil is on and it has been energized, and this contact is low. This is off and the contact is not low, it's up, and that causes the motor to rotate to the right. The current comes from here, it doesn't go because this is open, there is no connection to this not normally closed pin, so the current comes here through this 2 pins that are closed and goes to the positive, and from this side the negative goes through this 2 contact to the ground, and the motor will rotate to the right or clockwise. And here when you want to rotate the motor not in this direction but into this direction, now relay 2 is on and relay 1 is off. So when the relay 1 is off, the current will come here, passes through normally closed to this pin, and the positive, instead of connecting to the top, now it's connected to the ground. So we have changed the polarity of the motor, and as a result the positive cannot go this way because it's open. It will come through this contact, goes to the negative terminal, and exits from the positive, goes from here to the ground, and this time the motor will rotate to the other direction because this wire is now connected to the ground. Let me explain the wiring for the relay. I've labeled this relay 1, relay 2, and I've taped them together so they're not moving too much. This normally closed pin is connected from relay 2 to relay 1, so they are connected, and this goes to the battery, this wire. And then normally open of this relay has been connected to normally open using this brown wire, and from here I have put another wire from normally open which goes to the battery. So for the battery I have 2 wires, doesn't matter which is which unless your motor is very critical, otherwise just put positive or negative and then you will find out which way to connect it so motor rotates in your desired direction. And here the middle of this is connected to 1 wire of the motor, and the middle terminal, which is common, have been connected to the other wire of the motor. And here is my motor with 2 wires. From ground of Arduino I've placed 1 wire into this side that has blue color, so this is my negative or ground, and from 5 volts I've taken this orange to the side that is red. So this line will be all 5 volts and this line will have ground if I need it. And here for relay 1 the input will be connected to pin 2, and then for the second one will be the input will be connected to pin 3. And here those 2 pins, blue from relay 1 is connected to pin 2 and green from relay 2 is connected to pin 3. And finally I've connected this red, the left side of VCC using red wire, and VCC of this using red wire I've connected to the breadboard. To this red side, and the brown to this side which is negative. Here for this dual relay I've put 1 wire from this using this yellow wire to the other one, from normally closed to the other normally closed. So these 3 pins are for this, 3 pins for this, so the first pin to the first pin, and then 1 more wire from the same test pin, from the same pin, so this will go to the battery. And here from the normally open of this to the normally open of this I've put 1 orange wire and then from this pin one wire to the battery. So I have two wires for the battery, both one from the left side, one from the right side of this common. Now the middle two wires are left, so I can connect my motor here and here. These are the two wires of my motor. One is connected to the middle of this relay and the other is connected to the middle pin of this, so the common pins, and here is the motor. This is ground. This is connected to the ground of Arduino using yellow wire, and the last pin is VCC. This has been connected to 5 volts of Arduino. In 1 is for relay 1 and in 2 is for relay 2. And here in 1, green have been connected to pin 2, blue is connected to pin 3. Now let me explain the code. Using constant integer, I define relay 1 for pin 2 and then pin 3 as relay 2. These two are constant, so the code cannot change during execution, and the same way for push button 1 and push button 2 defined as constant integers, pin 8 and 9, so you can change these pins accordingly if you want to. And these three functions, actuator pull, actuator push, we know it, these are functions because of this opening and closing parenthesis. So, and then turn off, these are the three functions that are defined at the bottom of the code. Here they're called prototypes, so the code knows that these functions are coming later. Inside the setup we define using pin mode relay 1 as an output and then relay 2 as an output, 2 pins for the relay and 2 pins for the push button. But the difference is here we say input pull up. When we use this pull up, it means pull the pin up or connect it to positive using internal resistor. If you don't use this, then we have to use our own physical resistor, so that will be a lot of hassle. This makes it very easy. I have separate video explaining why we need to put a resistor or why we use this pull up, so the link will be below this video. Digital read push button 1, we read the push button 1 and we compare it if it is low. So when the button is pushed, it is always low because we used input pull up to pull it up or high. So this is when you push it, it goes low. So we check if this is true. While this is true, we continuously run this function called actuator pull. When you release the button, this function will not run. The same way we have while digital read push button is equal low, which means it is pushed, actual push is running. So this is pull, this is for push, which I'm going to explain it. And then inside the loop also we check the turn off. If the push button is not pressed, this or this one, the code will pass, the execution come to this line and will turn it off immediately after this. And the loop will continue, take the same action over and over again. Now let me show you the push and pull. Push and pull and off are here. When the push actuator push is running, digital write relay 1 low, this sets the relay 1 as low and relay 2 as high, so the current goes in one direction, and if it is pull, then it will be high and low. If you pay attention, this is low high and the other one, the pull, is high low. So this will cause the actuator to either push or pull, and the polarity will change. And if it is turned off, if the turn off is running, then we set both relays as high, and this way both relays are not connected and no current goes to the actuator, so it is turned off. Now this is the demonstration of dual relay module, exact same operation except it is the same, exact same operation except it is just a little cleaner. Instead of 2 power, I have only 1 power, and instead of 2 ground, I have only 1 ground. Other than that, everything is the same. And the power is connected, and let me push this. and I can release it at any moment. It will stop. As you can see, the red one on this side is pulling this. To change the direction, just switch these two, pin 2 and 3, the wires, if you want different push button for different purpose, because it's exactly the same. Now if I push this, it will go in, and this one still it will stop as well. I'm holding it. So the automatic stop still exists, has nothing to do with Arduino because that's internal. Now at this moment, if I press the push button, nothing will happen because internally the switch has kept this off and there is no current going to this. The relay is sending power, but this is internally disconnecting it. But this one now is ready. And now the same thing here. The relay clicks, but nothing happens because it's at the max and it has been turned off internally. Now I've connected everything. The relays are on. Arduino is also connected to the power, and external power is also connected. As you can see, the lights are on, and this red is for push, and this red is for pull, and this is for push. Now I'm demonstrating it when I push this. So the actuator is somewhere at some position. This is for push. When I push it, it goes, and this is for pulling it. I can release at any moment and it will stop. Thank you for watching. This was how to control an actuator using Arduino and 2 relays. If you learned something and found it useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe.